Okay, so this is part B. This is the triangle proportionality theorem. So with these particular problems, again, you are welcome to go ahead and look at the notes that are on Canvas if you don't want to listen to the recordings. But if you're confused by the notes, feel free to come and listen to the recordings. So if you need to pause, you want to do the problem by yourself and then let it play so that you can see if you got the right answer, those are great techniques. Okay, so first of all, this is a triangle and it has a parallel line. So if a line is parallel, that's again what these little symbols are right here, to one side of a triangle and it intersects the other two sides of a triangle, then the parallel line divides these two sides proportionally. Which what that means is these two segments that you get on this side right here are proportional to these two segments on this side. That got created because that parallel line happened to go right between somewhere in the triangle itself. As a result, you have this particular proportional statement. We can say segment AD corresponds to DB, and as a result, it's going to be equal to EC over BE. Now, you could flip that around, and again, it's just dependent on how you choose to set up that very first ratio. You could put DB, which is the top segment, broken up by the bottom segment, as long as you use top segment on the right-hand side ratio over the bottom segment on the right-hand side ratio. So either one will work. What's important to understand, again, is the order that you choose for this very first proportion. It controls what and how you set up the next ratio. So our very first example, I want to find the value of x. X is just one of the segments that is right here. Again, you always want to look for the little arrows because, again, as soon as you know that those two lines are parallel, then you can apply this particular theorem. If those lines are not parallel, you cannot assume that we've got ourselves segments that are going to be in correct ratios. So now you can choose. So just choose either one hand side of the triangle or the other to set up your proportion. Or sorry, set up your ratio that'll turn into proportion. So I'm going to take this segment here, 5.5, and I'm going to put it over 2, because that's what this particular theorem tells me. It breaks up that line, parallel line breaks up this triangle proportionally. Since I chose to have 5.5 in the numerator of my ratio, on the other side I have to pick the same segment that's in the same spot. X is kind of in the same spot as 5.5, it's just on the other side. So we're going to say x then corresponds to 3. Once you have your proportion, now you can cross multiply. Remember, cross multiply means that we are going to take the product of one diagonal, keep your equal sign, and then you're going to multiply the product of your other diagonal, which should give you 16.5. We want to solve for x. X is being multiplied by 2, so we're going to divide both sides by 2. And you should get 8.25 as your value for the missing segment. All right, our next example, slightly differently, there's a little twist to this one. You're being asked to find the length of segment CA. Now, our triangle proportionality theorem doesn't say anything about the whole side. It just tells us that the lengths of the sides are in proportion to the two segments. But that's okay, we can still find what we need. So I'm going to call this one segment that I don't know AD, we're going to call it X. So now I've got two segments on the right and two segments on the left, or you can think two segments on the top and two segments on the bottom. I have all the pieces that I need in order to find that little missing segment right there. So I could choose to say that 6 over 9, and that takes those two that are on the top and puts them in a ratio. And I'm going to keep the same ratio on the other side. Since I started with 6, I'm going to pick the segment that's there as well that matches up with it. And I'm going to put it over that little shorter segment, x. So again, once you have your proportion, we cross multiply. Cross multiply, again keep your equal sign, we don't lose the equal sign, and solve for x. But if we stop here on this particular problem, we're not going to be correct, because the problem was asking for us to find the length of CA. CA happens to be the sum of whatever AD was plus 5. So you have to add 5 more to your answer in order to get the final answer for this problem, which is 12.5.